This is a video on the third form of a quadratic, intercept form. So for intercept form, like the intro showed you, this is the actual form that we're going to be using. It can be y or f of x equals. So make sure you write down this information for your reference. Now in Algebra 1, you learned how to factor a quadratic. And when you factor a quadratic, you basically end up with something that looks like this, where you have two factors multiplied. And you also probably we're solving these, and remember, whenever we solve something, we're finding the x-intercepts. To find an x-intercept, you're finding what x is when y is 0. Now, the zero product property says if I'm multiplying two things and you get 0, it means at least one of them equals 0. So what you're actually doing is setting each factor equal to 0 and solving. So adding p and adding q to each side gives us these as our x-intercepts, p and q. Now our a value here is still the normal a value that's determining opening up or down and narrow or wide, just like it did for standard and vertex form. Okay, so let's take a look at the sketch here. If I were to plot just a random parabola, this would be p and this would be q. And we did a problem like this in class where I said, all right, find the axis. Can you find the axis? Can you find the vertex? The axis, because the height of the x-intercepts is the same and this is symmetric, the axis of symmetry is going to go right in between my x-intercepts like this. So if I want to find the axis of symmetry, what I can do is average my x-intercepts, or add them and divide by 2. So my axis of symmetry would be p plus q divided by 2. So make sure you write that down because we're going to be using it whenever we graph these by hand. So remember, the axis goes right in between the x-intercepts. And then once you have your x, you can plug back into the original for your x's to find your y's. So make sure this is all sketched down. And I'm going to do a few examples with you, and then I'll give you some problems to try on a PDF. Example 1. Let's start with this one here. So we're solving by graphing here. And remember, what we're actually doing behind the scenes is setting each factor equal to 0. I'm not going to do this from now on just because it's unnecessary work, but I'll show you one more time. Negative 3 and 1 are the x-intercepts. So if x plus 3 is a factor, then the opposite's an x-intercept. So basically just take whatever is opposite of the factor. So negative 3 and 1. Now sometimes whenever it's an easier problem, you can just eyeball it and see what is halfway in between these two, and it would be at negative 1. If you want to show work for it, the axis of symmetry would be, again, p plus q divided by 2. So there's p and q. And sometimes this work is unnecessary because you can just visually get it from the graph. But just to verify, that is why my axis of symmetry is negative 1. So I get that jotted down. All right, so my vertex is somewhere on this line, and I know that my graph is opening up because a is positive. I know my parabola is slightly narrower than the parent x squared because 2 is greater than 1. So let's go ahead and find the vertex. I need the y part of my vertex. So I'm going to find f of negative 1. Let's plug negative 1 in. 2 times negative 1 plus 3 times negative 1 minus 1. All right, let's find this. 2 times 2 times 2 is 8, and make it negative. So my final vertex is negative 1, negative 8. Get that jotted down, and then let's plot it. So at negative 1, 1, 2, 3, 4, 5, 6, 7, 8. And now I have 3 points. Now I have 3 points. I can graph a parabola. And that's pretty much all there is to intercept form. You get the x-intercepts, you get the vertex and axis, and you're good to go. So let's try a couple more just so you get the hang of this. Make sure that's all done and graphed. Now notice, I don't know what the y-intercept is. Actually, I'm going to make note of that here because we're going to be comparing and contrasting the 3 forms. Different forms have advantages. Like standard form, you can see the y-intercept, it's c. The letter C at the end. But if you're in intercept form, you can't see the y-intercept. You would have to actually FOIL this out and then multiply by 2 to get the y-intercept, which isn't that much work, but just so you know, you cannot see the y-intercept. You can see the x-intercepts, and you can see the axis and vertex. Okay, next one. I see a negative 1 up front. That's immediately making me think, all right, this thing's going to face down. It is neither wider nor narrower than the parent. It's just the regular width. So my x-intercepts are negative 1 and 5. negative 1, 2, 3, 4, 5. My axis of symmetry is negative 1 plus 5 divided by 2. Let's average this thing. So 2. Right in between my x-intercepts. My vertex, I'm going to evaluate the function at 2. So some function notation there. All right, let's get this y value. That's 3 times negative 3, so positive 9. Okay, 2 comma 9. So on here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I connect these, I get a parabola, opening down. Hopefully yours turns out a little bit smoother than mine. There we go. All right, I want to show you just a couple things here for the next ones. So make sure that's all written down. Pause it if you didn't get all that. All right, for these, I'm going to do them a little bit quicker just because there's just one thing you need to see. Whenever people factor and they get something like this, sometimes they get confused, like what's the x-intercept here? Remember, you're still setting each factor equal to 0. So when you set x to 0, you just get 0. That's one of your x-intercepts. That's it. Your axis of symmetry will be in between. So what I did here is I finished this problem off because this one is fairly simple. I just wanted to point out that if x is up front, you have x equals 0 as one of your x-intercepts. So finish copying this down. This one here, some people see the 6 and they're like, oh, one of my x-intercepts is negative 6 and the other is negative 7. Well, I would agree with the negative 6, but I would definitely disagree with the, I would agree with the negative 7, but I would disagree with the negative 6 because you have to set the whole factor equal to 0. So just use your basic solving, divide by 2. X is actually negative 3. So I have negative 3 and I have negative 7. 3, 4, 5, 6, 7. And then my axis is negative 7 plus negative 3 over 2, which is negative 10 over 2, which is negative 5, right in the middle. And then the last thing is to get your y value. Just be careful when you plug negative 5 into here that you're going to multiply by 2 right there. So just watch your order of operations. So this is negative 10 plus 6, which is negative 4. And then negative 5 plus 7 is a positive 2. So negative 4 times negative 4 is 16 times 2 is 32. All right, I obviously don't have 32 tick marks, so I'm just going to say that this right here is 32 and be fine with that. Clearly, this thing is very narrow. It goes way up because of the factor of negative 4 out front. That's making it upside down and much narrower than the parent function would be. So get your graph done, and on the website I have a PDF I'm going to post with some problems for you to do. All right, have a great Thanksgiving, and I'll see you after break.